Welcome to the Vitamin Professor podcast, brought to you by VRM Media, publisher of vitamin retailer and nutrition industry executive magazines, in partnership with Nutraland USA. I'm your host, Gene Bruno, Professor Emeritus of Nutraceutical Science and Chief Scientific Officer of Nutraland USA. The purpose of this podcast is to help educate the dietary supplement industry about the science of nutraceuticals and other relevant topics. If you like what you hear and see, don't forget to like and subscribe. Now, let me tell you a little bit about our guest today. Dr. Robert Nash is a renowned researcher in the field of phytochemistry who has devoted his career of IminoSugars. He's a professor at Aberystwyth University in the UK and a founder and leader of PhytoQuest Limited, which is developing IminoSugars for foods, pharmaceuticals, and cosmetics. Today, Dr. Nash is going to talk to us about Q-actin, a nutraceutical rich in IminoSugars and distributed by Gateway Health Alliances here in the US. Welcome to the Vitamin Professor, Dr. Nash.
Thank you, Professor Bruno. Very pleased to be invited to be in your show.
Yes, so let me just start. It's funny because I'm somewhat familiar with Q-actin. I learned about it some years back, and I was very excited about it for a number of reasons. In fact, I actually have written an article about it for one of the trade publications before, and I think that it's one of the most sort of undervalued nutraceuticals out there. It's just got so much going for it, and I hope with this particular podcast, people will get a sense of just why this is so special and something they should consider for their own formulations. But let's start with answering this question. What exactly are IminoSugars and how do they impact inflammation, particularly joint-related inflammation?
Okay, so sugars are very important to how the body functions, and aberrations in carbohydrate biochemistry are involved in many diseases, and are important signaling molecules in the body as well. So they coat all the cells, and cells can recognize each other and viruses and bacteria by the sugars on the surface, for example. So they're very carefully regulated. Now, aminosugars are, in their simplest form, simple sugars with a nitrogen in the ring replacing the oxygen. So IDO-BR1 is a particularly interesting amino sugar. In fact, it's an amino sugar amino acid. It has a nitrogen in the ring, but it has a carboxyl group, whereas most amino sugars have a hydroxymethyl group. So it's an analog really of not a sugar, but an iduronic or a uronic acid. And in fact, it's particularly an analog of iduronic acid, having the iduronic acid configuration. So aminosugars, they're colorless. They don't particularly have tastes. They're orally available. They interact with sugar receptors. They can bind very strongly to sugar metabolizing enzymes, much stronger than the sugars themselves, thousands and thousands of times stronger. So they can have very intense biological effects at very, very low concentrations compared to the sugars themselves. So IDO-BR1 has anti-inflammatory activity, and we discovered it primarily because we knew that cucumbers were anecdotally claimed to be anti-inflammatory. We had a look at cucumbers, saw one compound we didn't recognize, purified it, and identified it as IDO-BR1 and confirmed it by synthesis with collaborators at Oxford University who work with us confirming the structures of the natural products.
Very cool. So it works on a specific inflammatory compounds, and in that way, essentially helps with the inflammation. Fantastic. And it's not the same as, there's a lot of different botanicals out there that have impact on it, but this works a little bit differently, which I think makes it interesting. It's not exactly the same mechanism of action, say, as curcumin or something of that nature. That makes it a little more interesting. So what exactly is Q-actin and what is it derived from?
So Q-actin is derived from cucumbers. It's a standardized cucumber extract containing 1% or greater of IDO-BR1. So we identified IDO-BR1 as the main or probably solely anti-inflammatory compound of cucumbers. And so the Q-actin is a standardized product containing IDOBR1 at a level which you can be sure of.
Right. And I got to say that the first time I heard about Q-actin and I heard that it was a cucumber extract, I thought, wow, that's pretty cool. Because, people have all kinds of perceptions about different kinds of herbs and what might be desirable and what might not. But nobody objects to cucumber. Cucumber is pretty universally accepted as a healthy food, something that nobody has an issue with consuming. And so I think it's particularly makes it an interesting source of these compounds that have these anti-inflammatory effects. So I like the fact that it's from cucumber. Now, there are, I know, both animal studies and human studies on Q-actin. Let's start with animal studies. Can you tell us what some of the results of those were?
Yeah, so we've done animal studies primarily targeted looking at the toxicology, so showing the safety of the Q-actin product. And then we've done a number of in vitro and ex vivo studies on human-based systems looking at the mechanism of action. So we wanted, of course, to prove that IDOBR1 isolated from cucumber had anti-inflammatory activity. And we did that primarily, first of all, in ex vivo blood and in human cell cultures. We were able to show that it could significantly reduce the production of TNF-alpha, tumor necrosis factor alpha, which is an important inflammatory cytokine and does a lot of damage in joints, for example. So we were able to show that then the IDOBR1 was the main anti-inflammatory compound of cucumbers. And then of course, we wanted to know that the standardized product was safe. Of course, we knew it was going to be safe because it's from a cucumber extract.
Yeah, right.
There's nothing toxic in cucumbers, as far as we know, in significant levels anyway. So we then did animal studies looking at elevated doses of Q-actin. So it went up to 1 gram per kilogram in rodent studies. Again, there were no adverse effects, no effect on consumption of food, no weight effects. So it was safe this was over a 90-day study. So the animals received 1 gram per kilogram over 90 days, no adverse effects. And then there was an acute study doing 2 grams per kilogram. Again, no adverse effects from a single dose. So we also looked at mutagenicity, no mutagenicity seen giving the Q-actin. So all in all, it seems like a very safe product. So that was primarily the purpose of the animal studies. Then the in vitro, ex vivo, and to some extent human studies were then looking primarily at the mechanism, at how it worked.
So I remember having read that in one study on mice that pot inflammation progressively decreased within about 5.5 hours of receiving the cucumber, which is pretty amazing because a lot of times when you think of the use of a nutraceutical for reducing inflammation, you really need to see ongoing use for a period of time before you start to see anything. And to see a progressive increase within that period of time, I mean, to me, was somewhat impressive. So yeah, I think that's the animal research as a prelude to the human clinical research was all pretty nice. But now let me tell you, the first study that I read about Q-actin, the original one, as far as I know, was in comparing it to glucosamine and chondroitin, which at the time, glucosamine and chondroitin was kind of like the major joint health nutraceuticals. And so comparing it to that was, I thought, a very smart move. And I was really impressed at the comparison of Q-actin to glucosamine and chondroitin, especially when you look at the disparity between the doses. So can you tell us a little bit about that study?
Yeah, so as you're right, it was the first clinical study on Q-actin in humans with osteoarthritis. We chose a group of 122 people. with moderate knee osteoarthritis. And the idea was, as you say, to compare it with the most popular, the best-selling treatment for joint function and joint pain, which was glucosamine and chondroitin as a combination. And so half the people received glucosamine and chondroitin at 2.7 grams per day, divided into 2 doses during the day. And the other half of the subjects received Q-actin at 2 times 10 milligrams, so 20 milligrams per day. So an enormous difference in the dose. And yeah, so quite remarkable. I mean, I was extremely pleased that Q-actin worked at that dose, because it was the first study. There was a bit of guesswork about what dose would be required, and I was delighted that it worked at that dose. And the interesting thing was that glucosamine and chondroitin has an effect. I mean, it has effect in our study. It works to some extent in other studies as well. Has an effect, but the effect wears off very quickly. Whereas the Q-actin gives a progressive improvement in the condition of the subject,
which is amazing.
Over 180 days. So we did 6 month study. So it was a long study, and we measured the improvement in the patients using WOMAC, the VAS, and the LFI evaluation systems, and the Q-actin gave a significant result at each time point, whereas glucosamine wasn't significant statistically at any time point, and was much weaker. So over 180 days, Q-actin was given an improvement in the WOMAC score, for example, of 70%, whereas the glucosamine and chondroitin gave 33%, 34% improvement, but it wasn't significant over 180 days. And so, but I think it's the progressive improvement was really what really stood out for me, that actually it wasn't something that just happened over a period of time and then we're off. It was steadily improving. It looked like if you went over 180 days, you might even be able to totally solve the problem, certainly in some people anyway.
You know, and so many times you see in nutraceuticals where they're used for a certain period of time and you get almost a bell curve response, where you get a lot of response at once and then it kind of levels out. And this was not that. This was, it seemed to be a linear progressive. And I was, and just for our listeners who don't know, a WOMAC score is really the Western Ontario McMaster University's osteoarthritis index. Basically, it looks at physical function, stiffness, and pain. And so what impressed me was that at 30 days, you had just about a 30% decrease in that score. And then, as you said, 70% at 180 days. And it was so much less with glucosamine and chondroitin. And 20 milligrams was almost a shockingly low amount, especially when you look at 2,700 milligrams of glucosamine and chondroitin. Heretofore, the only other material I've seen that had a relatively low dose with some efficacy was a type 2 collagen. That was 40 milligrams, and this is half that, and it was very, very effective. So that was exciting to me to see those kind of scores. And by the way, for our listeners, WOMAC score was just one of 3 different types of scoring that was done, and all of them showed really amazing differences in the effects.
They're all significantly better than glucosamine and chondroitin.
Yeah.
Many times better than glucosamine and chondroitin. So the LFI score for glucosamine and chondroitin, for example, 180 days was 8%, whereas the Q-actin was 27%, which is a quite big difference. And it was huge. The gap between the two products was increasing over the 180 days as well, as the Q-actin carried on working and the glucosamine and chondroitin tailed off in effects. So we think it has that effect through the mechanism of action, which is decreasing the production of inflammatory cytokines like TNF alpha,
right?
Which in chronic joint inflammation, it does a lot of damage, and it also brings in other cytokines which also damage the joints. So we think it's able to give that steady improvement by reducing TNF alpha, not completely stopping it, which would be a bad thing. I mean, TNF alpha has a function. You don't want to completely knock it. but reducing it enables the joint to probably start repairing itself and perhaps improving the chondrocyte health in the joint. So that's why it looks really interesting that actually it's still giving improvement after 180 days.
And of course,
And
you made up.
what I didn't say, Professor Bruno, was that so it not only reduces TNF alpha, increases IL-10, decreases IL-1 beta, but it also seems to work via a number of different mechanisms. So, for example, when you get inflammation in your joint, you get an interaction between a receptor called CD44 and hyaluronic acid. And you get increased expression of CD44 in osteoarthritis in the joint. So there's a stronger and stronger response from the interaction of CD44 and hyaluronic acid. And one of the things which this interaction does, it leads to the induction of a sialidase, and these sialidases can further damage the connective tissue and cause more damage in the joint. So what IDO-BR1 does is, first of all, it interacts or interferes with the binding of hyaluronic acid to CD44, and we've shown that in cell culture systems. But it can also inhibit the sialidase, which is then induced and actually leads to further damage. So it seems to be working in a number of different ways, both reducing TNF alpha, inhibiting the hyaluronic acid receptor binding to CD44, and then also inhibiting the sialidase in the joint. So it's got multiple mechanisms which are all very different from the steroid pathway, for example, which would kill the pain but not stop the TNF alpha being produced.
Well, and I think that's the key. You mentioned, you don't want to stop inflammation, but when you're talking about a chronic situation like osteoarthritis, that ongoing chronic inflammation, then instead of being something sort of beneficial as part of an immune response, is detrimental because it keeps creating ongoing damage. And as you say, by reducing some of these inflammatory compounds, by sort of balancing some of these different compounds, the interleukins, just creating a different environment, it's allowing healing to take place that would otherwise have had. It's not that the body is incapable of healing itself, but what I like to liken it to is, let's say you got here's the metaphor. There's a brick wall out there, and you got a guy with a sledgehammer, and he comes around and he just starts knocking out one brick at a time. And then you have on the other side a stonemason who's coming up, and he's taking his brick and he lays down some cement, he's putting the brick on. But the guy with the sledgehammer keeps doing it too fast. So no matter how much the other guy's trying to repair the wall, it just keeps breaking down more and more and more. But if somebody were to stop that guy from knocking out the bricks, then the mason could start repairing it, and you could finally get to a place where the wall is whole again or in a much better shape. And that's what's happening in the body. So to me, the use of something like Q-actin is, preventing that ongoing damage and allowing the repair to take place, which to me is just so fantastic and really helps to set this apart from a lot of the different options. Not that you only can use, Q-actin, you could combine it with other things if you wanted, but just by itself, it has such promise as far as I'm concerned. Now, after the first study, there was another one done where you had a placebo-controlled trial. Could you tell us a little bit about that study?
Yeah, we wanted to do a placebo-controlled study because those are really the gold standard in clinical studies of these types of products. And it's well known in osteoarthritis that there can be a strong placebo effect. And in fact, that seems to be what was shown in the GATE study, for example, the very large osteoarthritis study. There was a strong placebo effect, and it wasn't very clear whether glucosamine and chondroitin were really having a significant effect over placebo. So what we wanted to do is do a placebo study, comparing Q-actin with placebo and just showing that it was greater than the placebo effect. So we did a placebo group, a 20 milligram Q-actin group, and 100 milligram Q-actin group, because the other thing we wanted to show was there was a dose response.
Yeah.
So this was in 91 subjects, again, a similar group with moderate knee osteoarthritis. Again, we used the same scoring methods, so the WOMAC. the Western Ontario McMaster's University's Osteoarthritis Index, the VAS score, which looks primarily at pain, and then the LFI, which looks again at function and mobility. So we again were able to show a very significant effect at all time points. Again, 180 days, measuring effects at every 30 days. So at every time point, there was a significant improvement over the baseline for both Q-actin doses. But there was a greater effect with the 100 milligram than with the 20 milligram, but not a significant, I shouldn't say significant, but not a big difference between the two. So both doses were effective and both gave significant effects. So for example, the placebo was giving an effect 180 days of 5%, whereas the 100 milligram Q-actin dose was giving a 40% in the WAMAG score. So a big difference there, and a very big difference in the LFI score as well, with the placebo giving around 13% improvement and the 100 milligram Q-actin giving over 50% improvement in the LFI score, showing function. And there was a big difference in the VAS score as well, so the pain result with the 100 milligrams. But there was a strong effect also with the 20 milligrams. So there wasn't really a big difference between 20 milligrams and 100 milligrams. So there was 32% improved 180 days with the 20 milligram, 40% with 100 milligrams. So there's a dose response, but actually they're still both greatly better and significantly better than placebo at all time points.
Right. So using 5 times more of the material didn't have 5 times greater impact.
No, it doesn't seem to. No.
Yeah, and so it still worked really, really well at 20. So 20 milligrams is a great dose, an efficacious dose, and quite a manageable dose. Yes, 100 milligrams worked better, but as you say, not in such a significant way that you're going, oh wow, this is the dose you have to use. 20 milligrams is quite reasonable.
Yes. Yeah.
So just because I'm not sure, I'm going to ask you, are there any other Q-actin studies that are planned or any others that have been done that I didn't know about?
Well, we've done a number of preclinical studies in addition to the clinical studies. So obviously we looked a lot at the mechanism and toxicology, but another interesting thing about aminosugars is that they're never cytotoxic. I mean, this is one of the interesting properties of aminosugars. They're not cytotoxic, they're orally available, and they're not metabolized, so they're not incorporated into anything. They react with receptors, enzymes, and then they're eventually excreted completely unchanged in urine. So that's something we have done in terms of other studies with Q-actin as well, showing that the IDOBR1 isn't changed, and it's extremely stable in the product as well, which obviously is a product advantage. The shelf life is extremely long, even stored in our lab here at ambient temperatures. The IDOBR1 just doesn't degrade in a measurable amount over years. So
that bodes very well for stability.
Yeah, so great stability. So the other study we were very interested in, because inflammation, as you know, is involved in all sorts of
all kinds of disorders.
Yeah, with aging. I mean, inflammation gets worse as you get older, and it causes all sorts of problems. So obviously, cognitive decline, dementia, brain health, something we were very interested in, because it's been suggested by a number of workers that neuroinflammation is actually involved in cognitive decline, development of Alzheimer's, Parkinson's. And one of the main cells thought to be involved in this brain inflammation are microglia. They're a type of immune cell in the brain, and they can become activated and produce all sorts of inflammatory cytokines, including TNF-alpha, IL-1 beta, nitrous oxide, and that causes inflammation. Again, that could presumably become chronic inflammation. So we wanted to study Q-actin and IDOBR1 against the activation of brain microglia in culture. So we used a microglial cell culture. It's a mouse line, BV2. It's a well-known model for looking at microglia inflammation. And we're able to show that the IDOBR1 and indeed the Q-actin was very effective at reducing the release of inflammatory cytokines in response to LPS in these cell cultures. Again, there was a
Oh,
response. It also seemed to reduce the activation of NF-kappa B, which is a
oh, yeah.
pathway involved in inflammatory processes. So because IDOBO1 and aminosugars in general are very orally available, seem to enter the bloodstream very rapidly and probably actively transported because they resemble sugars or amino acids
Sugars, yeah.
so much, they may well get into the brain. We haven't done that study yet. We're interested in looking at whether
It's
they
very
can
promising,
the
though.
brain
I mean,
barrier, but they're very likely to, because the body's unlikely to distinguish them from the sugars and amino acids which they resemble so closely. So we think there's a real opportunity for looking at Q-actin, for looking at improving neurodegeneration, for improving brain health and function and reducing inflammation in the brain. So it is well known that controlling inflammation in the brain can be beneficial, but you need to get something in there that doesn't damage the brain in actually putting it into the brain. So you can put some anti-inflammatory compounds injected into the spinal column or the brain, but it actually does damage in doing that. So something that passes through the blood-brain barrier by itself would really be a very good way of actually controlling inflammation in the brain. And IDOBO1 Q-actin looks like it has real potential for doing that.
wow, that is a tremendously promising area of research. I mean, if you can, you talked about, aging and inflammation, and of course the term had been coined inflammaging,
Yes,
to
yes.
describe the role of inflammation in the aging process, including but not limited to brain aging and some of these conditions. And if you're able to demonstrate that it passes the blood-brain barrier, or just that you're getting some good clinical results with this, that's exciting. That's a whole new area of research. That would be very, very exciting. I mean, alone, just looking at the effects on joint health, looking at the millions and millions of people suffering from osteoarthritis who could get some very promising relief with Q-actin. That alone is fantastic. But when you can
Yes.
start looking at the brain and brain aging and the effects there, that's really exciting. And also, I've mentioned it in another podcast before, but there's some trends in the industry towards ingredients that are, polycrests that basically have multiple effects in different
Yes.
areas. And this looks like it could. It could have effect not just for joints, but potentially for brain. And who knows what else, if it, what other areas of the body it could have those anti-inflammatory effects for. So, I mean, the future is very promising for this material. And as somebody who, in my 45 years in the industry, for about 37, 38 of it, I've been formulating, one of the things you always look for is ingredients that you can put in a formula that have a lot of things going for them. And I know what I think this has going for it, and I want to share that. But first, I'd like to ask you your opinion on what do you think the advantages are for brand owners considering using Q-actin in a dietary supplement. What do you think are some of the major advantages?
Well, the dose, of course, is a major advantage. The low
Yeah,
dose, that makes it very amenable to incorporation into other supplements. You can combine it because the amount of this supplement is so low. You could actually combine it if you want to, or it could be used as a single active ingredient. It has it's produced as a powder, so Q-actin is a powder, so it's very good, very easy to formulate it into other products. It can be has favorable formulation properties for putting into capsules, tablets as a free-flowing powder. It could be also incorporated into soft gels, and in fact, we've looked at doing that, and it also could be put into liquid delivery systems such as shots, stick packs, and effervescence as well, because it's a water-soluble active compound and it doesn't particularly have a taste or strong color. The dose,
and
which
that is particularly important because these days we're finding, like, for example, gummies are something that have been very popular as a delivery form. But if you look at the latest SPINS data, although gummies are still huge, they've actually had a slight decline as a delivery form, but it's still huge, and there's subcategories of gummies that still are performing very, very high and increasing. And so something that has a essentially neutral taste, and it's so small anyway that even
Yeah.
if it didn't,
Yeah.
you could easily mask it, but it has a neutral taste, a small amount. It's going to be easy to use in alternative delivery forms like gummies. Some of the other ones that are gaining some traction are the oral strips that they'll use as a delivery form. And you have a limitation on how much you can include in there. But again, with such a low dose like this, that would be so simple. And people
Yeah.
are using fast melts and little lozenges and these kinds of things.
Yeah.
All of those, this would be a perfect system because, again, you get some older people who have trouble swallowing pills, whether they be capsules or tablets.
Yeah.
And to be able to have an alternative delivery form, like could be a gummy, could be a strip, could be a fat, could be any of those things, but that they can take, and it's going to be easy to consume, and it's not going to taste bad, because we know in this business, no matter how good it is, if it tastes objectionable, they'll try it the first time and they won't again, even if it helps them. And so to me, this has such good parameters, physical parameters, taste, all of that, and the dosing level is so low. It's like a dream ingredient. And then let's not forget the obvious, which is you've got 2 solid clinical studies on this, human clinical
Yes.
studies, and all the pre-work.
Yes.
You've got safety, you've got studies showing it's efficacious. And of course, whenever we're talking about something that's been used in osteoarthritis, you take a page from the what glucosamine and chondroitin products have done over the years. You can't, in the United States anyway, I can't speak for all regions of the world and all their regulations, but you can't say, oh, this helps to treat osteoarthritis, but you can talk about the impact that it has on joint comfort, joint
Yes.
mobility, joint
Yeah.
flexibility. And
Yeah.
with the individual, the WOMAC, the VAS, the LFI, with all of those, you have the data to support those kinds of, let's call them slightly more vanilla claims, but everybody knows what that means. And so
Yes.
you're
Yes.
able to make the claims you need to make at such a low dose. And, I think that's fantastic. Just a matter of curiosity, as somebody who's done a lot of formulation, with your background in phytochemistry, can you think of any nutraceuticals that you think Q-actin would be particularly well suited to be combined with in a formula? If you got companies out there who's like, ooh, I like the Q-actin, but I don't want to have a standalone. I want to combine it with something else. Or maybe they already have a product that has some nutraceuticals in it that they might like to add Q-actin to. Can you think of any that you would say, this would be good to combine with this nutraceutical?
It's not something I particularly thought about, to be quite honest, Professor Bruno. So I'm not sure what to answer to that. But it
No,
could
that's fair enough.
it could be combined with other products very easily because of the small dose, and also because the molecule is very water soluble, so it's going to come out of whatever you formulate it with. As soon as you consume it, it's going to be released because of, there's a lot of water in the body. It's acid stable. So it's going to be released and come out probably whatever it's mixed with. The Q-actin IWR1 is still going to be effective. And it's very non-reactive, which is the other thing. So whatever you combine it with, it's not going to react with anything. So you're not going to harm the activity of the Q-actin, whatever you put it with.
So I'm going to share a couple of, thank you for that. And I'm going to share a couple of my thoughts on that, because let's say if you're a brand owner and you already have any of the following nutraceuticals in your line, or you're looking for something to combine it with Q-actin, things like, of course, all of the curcumins of the world, and there's many of them out there, assuming you're using one that has good bioavailability, that can work very nicely. The boswellia extracts can work very nicely. Pomegranate ones that have had studies on them as anti-inflammatory agents can work very nicely. And even some of the collagen materials, whether they be the type 2 collagens that have had some very, very good research done on them, as well as even the type 1 collagens that have had some research done on them for for joint health. And what's nice is everything here doesn't share the same mechanism of action. If everything were the same mechanism of action, you'd say, well, that's just redundant. But when you combine the uniqueness of the mechanism of action of Q-actin together with any of those, you're not having redundancy. You're having an additive, a complementary effect, as opposed to a redundant effect. So I would encourage everybody out there to strongly consider the use of Q-actin. I mean, the 20 milligram dose is just phenomenal. When you talk 20 milligrams, you talk neutral taste. I mean, that's just, safety. It's got everything that you could possibly want. So I think that is, just a primary consideration for anybody out there.
We probably shouldn't forget some glucosamine chondroitin as well, that
Of
combining
course, glucosamine chondroitin.
actually they seem to have some beneficial properties. So actually putting Q-actin in may help that work a lot better and provide some of the building blocks which are needed to do the restoration of the joints, for example.
You're right, because the glucosamine chondroitin can help support repair. But you still have to have something in there that's stopping the ongoing damage before that repair will happen. So you're right. Look, that's a good point, Dr. Nash, is that combining it with even glucosamine chondroitin can be a great thing. And if you're using 2,700 milligrams of glucosamine chondroitin, you don't have a lot of room left to put anything else in there. But you could absolutely fit Q-actin in there at 20 milligrams. If you're
you may be able to reduce the dose of glucosamine and chondroitin below 2.7 grams as well. You could do perhaps half the dose and maybe still have an effect.
Yeah, and there's some research on lower doses, particularly of, or even just chondroitin by itself. So it could be nice. So do you feel like there's anything else you'd like our listeners to know about Q-actin that we haven't already covered, or any emphasis that you'd like to place on something we already covered?
Well, I mean, as we mentioned at the start, cucumber's got a very positive impression with the public. I mean, people are well aware of the anecdotal claims for it being soothing the skin, being used in face packs. So you see the ladies with the cucumber rings on their eyes for reducing puffiness, redness around the eyes. And there's a belief it has some beneficial properties. So what people don't know, though, is which cucumbers they should eat, because there are around 4,000 cucumber varieties now, bred for all sorts of different reasons. That most of the supermarket varieties are bred for shelf life or transport life, not necessarily for taste or certainly not IDO-BR1 content. So we've looked at a lot of the common commercial varieties these days, and they contain no IDO-BR1. So just taking a cucumber may not mean you're getting any anti-inflammatory activity at all. In fact, it probably doesn't. Right. So you just buying a cucumber, I wouldn't know whether it's got IDO-BR1 in or not. It's not just variety; it's also the growing condition. So we found some varieties, for example, that produce a very high level in one condition, and the next year they'll produce absolutely nothing, just because the weather's slightly different, the conditions are slightly different, maybe the age of the cucumbers is different. So you really need to know you're getting the IDO-BR1, and that's the real advantage of Q-actin, that it's standardized to a particular level of IDO-BR1. But I think the public believe that cucumber has benefits, but using Q-actin, they know what they're getting, and they know they're going to get those anti-inflammatory.
Absolutely. That is such an important point. Not too long ago I'm pretty active on LinkedIn. It's the only social media I am active on. Talking about our industry and the science and all of that sort of thing. And somebody was making the point that, there's a position of food over supplements. And I get that as a general rule, but there are some foods that simply can't and don't provide an adequate amount of a given nutraceutical to be able to have the benefit. What the example at the time that was given was creatine. If you look at the amount of animal proteins you'd need to consume to get an adequate dose of creatine, it's a huge amounts that nobody would be consuming. And just simply to be able to say, I'm just going to take 5 or 8 grams of creatine monohydrate, and you can get the benefits of it from that. From a sports nutrition perspective, you simply can't do that by eating the food. And I think similarly here, that you don't know if you're getting the IDOBR1 in any sufficient amounts if you eat any given cucumber. And I know, I have a background in herbal medicine as well, and I know that it's certainly been shown. You can have herbs grown in a different region, or even in the same region, maybe on the other side of the mountain, or at a different time of year on the same thing, or the weather's changed, and it can change the profile of the phytocompounds that are present. And so it's vital that you assure that you have an adequate amount of the active compounds. And that's, what you've done here with QAct. And so again, to me, it's just the way to go. And if ever there was an unsung hero in the inflammatory herbal world, it is QActin. This stuff should be it should be readily available in every vitamin store, every drug store, every supermarket. It should be everywhere that anybody can get a hold of it. And that it isn't yet, I think, is a darn shame. But hopefully in some small way, people hearing about it here on the Vitamin Professor will get a better understanding of what this is and start to promote it. And the nice thing about it is once they put it in their formula and start to promote it, people who use it are going to get good results, and it's just going to take off. At least that's my opinion. So
yeah, it's a very, very interesting compound and product, and it's remarkable how effective the compound is, and it was a great surprise to find it in cucumber extracts when we first found it.
I bet it was.
and the reason people had missed it is it looks just like a sugar or an amino acid. I mean, if you look at a cucumber extract and you don't have the reference compound or the familiarity with amino sugars, you just won't recognize it. It just looks like a standard sugar amino acid until you could run the reference compound and you can see that actually it's different. And that's the interesting thing about amino sugars. They're probably in many herbal medicines and foods. In fact, we know they are. But most people just don't recognize them as being components in those foods. They just look like sugars or amino acids. And so we've identified around 200 amino sugars now, and occurring naturally. And they all have very different biological properties from each other based on the stereochemistry of the hydroxyl group. So, you can change the stereochemistry of IDOBR1 and it won't work anymore. It's very specific to the stereochemistry. And the interesting thing about cucumber is it only has one amino sugar. That made it easy in some ways for us. We saw one peak, we purified that one peak, and lo and behold, it was the anti-inflammatory compound. But
Nice.
without the reference compound, you wouldn't recognize, and most people still wouldn't recognize it as being present in cucumbers because they wouldn't see by their analytical methods.
Yeah, and that's important too, because as you say, it might be and it probably is in some other things out there, but unless you are a lab that has a methodology which you validated and you have the reference compound to test it against, you don't really know. You don't really know if it has that. We know this has it, and we know it has it in the right amount. So
yeah.
Very good.
Well, IDOBR1 is extremely rare. We've looked at, hundreds or thousands of herbal medicines, food plants, and IDOBR1 is not a common compound. That's why it stood out in cucumbers, because we didn't recognize what it was. And so we targeted it for identification. It was only because we were working with chemists at Oxford University that we managed to work out what it was by doing the synthesis and showing that compound had the particular stereochemistry and was anti-inflammatory. So, they're not easy compounds to work with because the reference compounds aren't there, but IDOBR1 is extremely rare, and that's why the cucumber extract is so valuable, because it's not a common compound you can consume readily from other materials you might eat.
It's actually kind of amazing that you were able to isolate it, and under the circumstances, given its rarity.
Yes.
So that was pretty cool.
It was luck we were growing the right variety. We were interested in the anti-inflammatory claims around cucumbers. We decided we'd look at some cucumbers we were growing in our greenhouse at home. It just so happened that particular variety and the conditions we were growing it in had the compound, and had we looked at another cucumber, we might not have seen it because it may not have been there. So there was a lot of luck involved, but it was all based around the anecdotal claims around cucumbers that led us to think, that's the compound. This is the elusive anti-inflammatory of cucumbers. There it is, and lo and behold, it was when we isolated it.
It's almost like all the stars were aligned and everything
Yes,
just happened in
yes.
the right way to
There's
make this.
a lot of serendipity in herbal medicine research, I think, and yeah, we were very lucky then.
Very cool. Well, Dr. Nash, I want to thank you for joining us on the Vitamin Professor today. I think you've provided some great information on Q-actin, and hopefully we have educated the dietary supplement industry a little bit more about this. And I'm hopeful that more brands will start using Q-actin, because I think it would make a huge difference out there for consumers, and helping them with inflammation, particularly joint-related inflammation, and maybe more.
Yeah,
So
it's a very exciting use of our research. It's a very interesting molecule. It would be great to see the molecule and the Q-actin product moving forward and actually really helping people.
exactly. So again, thank you for joining us. And to our listeners, I want to just remind you that if you like what you heard, don't forget to like and subscribe. Thanks again, Dr. Nash.
Thank you very much, Professor Bruno.